So let's solve our first quadratic, and we're going to do it by factoring. So can we factor this trinomial that we have here? Well, we remember that we begin with some parentheses here, and I'm going to set it equal to 0 because it's an equation. I don't want to lose that. I think I have a 2x and an x. From there, I want to look for factors of -4 that help me get to a 7. So it looks like a +4 here and a -1 there. So I was able to factor this trinomial down correctly. And then from here, I have use of my zero product principle. So this is true, or I have solutions when either this first term equals 0 or the second term equals 0. Solving for that, or solving for both of them, I get a 1/2 as one solution, and over here it looks like an x equals a -4. And from there, we can check to verify that these solutions work. So one way to, or how I would check, 2 times x is 1/2, square that, plus 7 times 1/2, minus 4, does that equal 0? 2 times 1/2 squared, that's 2 times 1/4, makes it 2/4, plus 7 1/2, that makes that 14 15/2, minus 4 equals 0. Let's kind of add these guys get up, so let's get common denominators. 2/4 plus 30/4 minus a 4. 2/4 plus 30/4 equals 32. One half squared is 1/4. 2 times 1/4 is 2/4. 7 times 1/2. Oh, it's not 7 and 1/2. It's 7 times 1/2. I was wondering what's going on here. Let's start over here. So I have 2/4 times 7 and 1/2, which is 7/2, minus a 4 equals 0. Thought I was converting fractions, mixed numbers, but I'm not. I was multiplying. Add those by common denominators. So that's 2/4 plus 14/4 minus 4. 2/4 plus 14/4 is 16/4, which is a 4. 4 minus a 4 does equal 0. So 1/2 is a solution. That's a valid solution. And then checking that -4. -4 squared is 16. 2 times 16 is 32. Plus a -28 minus a 4. 32 minus 32 does equal 0. So that's a proof, or that's confirmation that my two solutions are the correct solutions. So my solution set is 1/2 and -4. Now notice this isn't a coordinate point, rather it's a solution set. Another potential quadratic here. Let's get it in standard form, which means I set it all equal to 0. So I'm going to subtract 2x from both sides. I'm going to factor, because we're solving quadratics by factoring, so it looks like I can factor an x from both of these. And then what's left is a 3x minus a 2. My zero product principle tells me if the first term or the second term, if the whole product equals 0, then either x equals 0 or 3x minus 2 equals 0. And let's find those solutions for x. One, we're already there. The other one, solve for x here. And there's my two solutions to this quadratic. X equals 0. And the other solution is 2/3. And there's my two solutions for this particular quadratic. Let's give this one a try. Again, we're throwing in a little bit of a wrinkle for you so you see them here first. You get the confidence that you can do them. You can go tackle your practice problems and gain more confidence by doing the work yourself. So how do we solve this? Let's first put the quadratic in standard form. Let's factor that. Oh, do you guys see what I see? That looks like a perfect square trinomial. So this factors down to x minus 3 squared. Kind of cool. From here, I really have it x minus 3 times x minus 3. This is what it really means. So for this to be true, either x minus 3 equals 0 or the other x minus 3 equals 0. So in both of those cases then, x would equal 3. So there's my solution set of just x equals 3, and I would write it in solution set form. And there's my solution set. And I could check that. 3 squared is 9. 9 equals 18 minus 9. 9 equals 9. So that is a valid solution. Another example. What do you guys want to do? Yeah, I'm waiting on you guys. Standard form? Sure. Factor? Okay. Yeah. One of my favorites. Difference of two squares, isn't it? So this factors down to 3x minus 4 and 3x plus 4. Set both of these products equal to 0. So one is 3x minus 4 equals to 0. The other one is a 3x plus a 4 equals 0. And solve them both out. X equals 3/4 over here. And x equals negative 4/3. So my solution set is 4/3 and negative 4/3. Isn't it wonderful how much our factoring comes into play? And the more of a handle that we have on our factoring makes solving these quadratics a little easier. X minus 2 times x plus 3 equals 6. How do we solve this? Do we go straight to this idea? Maybe we'll do an x minus 2 equals a 6, and then x plus 3 equals a 6? No, we can't do that because that only works when it's 0. That's why it's called the 0 product principle, not the 6 product principle. So what do? Well, we got to convert this to standard form somehow. So it's going to require a couple of steps. So let's multiply this through and get a trinomial. So x times x, x squared, outer terms, inner terms, last terms. So basically it looks like all I did was to multiply the binomial out. I want to get it in standard form, which means that it's a quadratic equaling 0. So I'm going to subtract 6 from both sides. Okay. I had 4 lines of work to do to get it to something that I know what to do with now. Let's factor this. And that factors to a positive 4 and a negative 3. And then from there, this is true if x minus 3 equals 0 or x plus 4 equals 0. And there's my solution set. 3 and negative 4. So you notice on this problem, there was some work I had to do. First of all, I had to recognize, one, that I couldn't use a 0 product principle to begin with. that only works when it's equal to 0. All right, so I have to scratch that off. The other thing is I know that I can solve quadratics by factoring if they're in standard form. And this was nowhere near standard form. So I had to do some of my algebra skills, or use my algebra skills, to work it down so I can finally get it in standard form. Then once I was there, then I can go through, factor, use the zero product principle finally, and get my two solutions.